I had pulled all of these different types of technologies, used them in unconventional ways. So I was very proud of this device. We got it to work. So I thought they'd ask me how it worked. No, they asked me why I thought this was a good idea. Why would anybody want to look at their pictures on a television set? What would an electronic photo album look like anyway?
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.
Greetings and welcome along to the New Zealand Tech Podcast. I'm your host, Paul Spain. Today, I'm in San Francisco, but this recording is one that was made previously in Rochester, New York, with Steve Sasson, the inventor of the digital camera. That's right, Steve Sasson is an American electrical engineer who during 1974 and 1975 invented and built the first ever self-contained digital camera, and also some years later the first digital SLR camera. I visited Steve at his home in Rochester, New York, where we discuss Steve's pioneering work with technology at Kodak, including his groundbreaking innovations that paved the way for digital photography as we know it today. We'll explore some of the technical challenges, organizational hurdles, and cultural shifts that accompanied this revolutionary work. This first digital camera could store a tiny image, just 100 by 100 pixels, black and white, and could store those on magnetic media and display them on a TV. Sasson shares his insights on the delicate balance between innovation and tradition, shedding light on Kodak's missed opportunities and the broader implications for companies navigating today's fast-paced technological landscape. This episode offers a deep dive into one of the most significant technological shifts of our time, one which ultimately saw Kodak's business disrupted by those who had no old business model to protect, but everything to gain from success in the world of digital photography. The podcast was recorded some years ago on a previous visit to Rochester, New York. We recorded this podcast at the home of Steve Sasson, who was kind enough to make that opportunity available. I'm super excited to share this episode with you, and of course want to offer a massive thank you to our show partners who really have made this episode and many, many others possible because of their support. So without further ado, big thank you to 1NZ, Spark, 2 Degrees, HP, Workday, and Gorilla Technology. Let's jump in with Steve Sasson. Very honoured today to spend some time with Steve Sasson. Thank you for joining me.
Oh, thank you very much, Paul.
Now, Steve, yours was a fairly interesting story. You've started out after studying. You ended up at Kodak and really were involved in some very groundbreaking inventions and discoveries over a period. So I wonder if you can start out by telling us a little bit about how you ended up at Kodak and this role that you found yourself in that had you playing with CCDs or charged coupled devices, which ultimately led to the invention of the digital camera.
Well, I went to university at Rensselaer Polytechnic Institute, and I graduated from the university with a master's degree in electrical engineering in 1973. And I had always been interested in electrical engineering, and I loved building electronic things. When I was a kid, I used to build transmitters and stereo amplifiers from parts I would scavenge from old television sets that people would, when they threw them out on the curb, I would bring them home and dissect them and take all the parts up. So I was a builder by nature. And so when I entered Kodak, I joined Kodak, and they didn't have a history of hiring a lot of electrical engineers back then. But the photographic state of the art at the time, conventional cameras, were more and more of their unit manufacturing cost was being associated with electrical components, film advance, shutter controls, focus, that kind of thing. And so I was sort of on one of the first crop of sort of electronic guys that they hired. And I hired into an applied research laboratory at the apparatus division for Kodak. This was a big division that was responsible for the design and manufacture of all of the equipment that used the sensitized goods that was traditionally manufactured at Kodak Park, another big facility here in Rochester, New York. And so in this laboratory, it was a fascinating place. It was there were different groups with different disciplines, and I hired into what was called the electronics group. And there was maybe 8 or 9 engineers in that group. And I came in with a few other young engineers. And this laboratory was dedicated toward applying the different technologies to solving problems for the company in terms of its equipment, whether it would be proposing new products or solving problems on existing products or helping with manufacturing technology issues. It was a very broad place to work. And there were other groups in the lab as well. There was a math group, a physics group, a chemical group, all kinds of things. So really a cool place for a young engineer to end up. And my supervisor came to me one day. I had been working there for about a year plus or so. And you usually handled several projects when you were there, especially as a young engineer. You weren't really given super important stuff to do. You were learning. And so he came to me and said, here I've got he gave me a choice between modeling an XL movie camera exposure control system or looking at this new type of imaging device called the charge couple device that had just commercially become available from a company called Fairchild. And I jumped at the chance to do the CCD work because at university I did my master's thesis on how light affected silicon. I built something where light would control the flow of current in a motor, and so I was interested in that. I was predisposed to do that.
But this was pretty early in terms of that type of electronics.
Oh yes, it was. Nobody at Kodak, to my knowledge, had actually played with this particular device or any device like this before. This was an area array, which meant it was a two-dimensional mosaic of photosites. There were 100 on each line and 100 lines. So there were 10,000 pixels, as we call them today. And it was it meant such that when you exposed light to it or a scene, and you imaged a scene on this, it would create a corresponding charge pattern that corresponded with the light at the different points on the surface. And then the charge coupling mechanism allowed you to take out each individual pixel in a certain order, so that you could take this charge pattern and turn it into a electrical voltage pulse pattern, and then that could be used to recreate that scene. And these devices were very crude. The conversation with my supervisor, whose name was Gareth Lloyd, probably lasted 45 seconds. I mean, it was. I said, yeah, I'd love to try that. And he said, okay, get one, play with it, see what you can do with it, see if it can be any use for us. We're going to learn about it.
So what do you think initiated that from his perspective? What was his role in that process? Did he came across new innovations and technologies that were available from other firms and just wanted to make sure your competency was kept up at such a level within Kodak that you understood when and how you might use these things?
Yes, it was basically his charter, the charter of the laboratory I was in, as well as each individual group's charter, was to stay on top of all the relevant technology that was within your domain. And so electronics, of course, is a very dynamic area. And so anytime there were new devices or new technology that might be applicable, we would explore it. This particular exercise was pretty far out there. I mean, there was no immediate application for this at all. I mean, these devices were very experimental. I like to tell the story that when I ordered this device, it came it was a 24-pin dip, as I remember, a dual inline package, and it came, as they traditionally did at that time, in a styrofoam box with the pins plugged in. And then on top of it was folded a piece of paper when you opened the box. And on top of it was written 12 voltage measurements. There were 12 different voltage pins on there that represented the clock voltages that you needed to get this to work. And next to each one was written in pencil the actual voltage that this device worked at when it left the factory. So
Okay.
handwritten. And then at the bottom it said, good luck. Because they
What
were,
do you think this thing was worth?
it was several $100s. And this was back in 1973. So this was a bit of a purchase. I was only allowed to buy 2 of them because they figured I'd blow one up before I got anything out of it. And that was all I was permitted to buy. There was no carte blanche to buy anything else. It was just buy this thing and just evaluate it, And we had a lot of parts in the laboratory. One of the great things about working at Kodak is, especially in a research laboratory, is they have lots of cool parts and stuff and measurement equipment and things. And so I could utilize that to evaluate it. But that was about the whole charter. Nobody told me to build a camera or anything like that. But my reasoning was simple. I thought if I could get this to work, which was my challenge, get it to work, I would eventually have to shine a light on it and do exposure of some kind to get the charge pattern out. And then I would have to measure its performance. Well, what's the best way to measure the performance of something? Well, to turn the output into a series of numbers, because I was going to have to come up with numbers, right? And so I said, well, okay, if I digitize the output of this thing, because each pixel came out as a voltage pulse to turn it into a number. And then I thought, well, if I'm capturing numbers, then I'll have to store the numbers, and I store the numbers in electronically. And then I thought, well, okay, in a way, I'm creating some sort of an imaging device. I'm storing a temporary light image permanently electronically. And so then I thought, well, I could build a camera with this thing. And so I thought I'd build an all-electronic still camera. Then, because I was an electronics guy and I was surrounded by mechanical guys, because cameras were mechanical marvels at that time, right? Moving film and exposure and everything. I thought, wouldn't it be cool to build a camera with no moving parts at all? I thought that would be really cool, right? One, I wasn't mechanically oriented, so I didn't know how to do it anyway. So the irony was I built the first digital camera, but I couldn't have built a conventional camera at that time. So it helps not knowing some things, I guess. But
Well, I guess it's because you looked at things through a different lens. You had a different perspective on things that you were able to come up with this innovation, right? I mean, obviously the environment there was the right sort of environment to be innovating in, and I'm sure there were lots of other inventions and creations through these labs over the years, but there probably wouldn't have been anybody else in your group that would have come up with the same concept.
Well, I think, remember I told you when I used to build everything when I was a kid?
Yeah.
That's how I expressed myself. When I had an idea, I didn't like draw a picture of it. I would build it. And my form of expression was electronics. And I also mentioned I worked there for about a year before that. And I had built a lens cleaning machine, a machine that would automatically clean lenses for projectors. And I used digital technology. So that's why I learned about digital technology, SSI technology. And so that was in my head. And I thought, I was basically freezing time. When the image came out of the CCD, you had to read it out very quickly, or otherwise the image would disappear because of the charge that would be generated thermally inside the devices. And so I said, I've got to read it out quickly and store it somehow. Now, I could have read it to videotape or something, but I didn't know how to do that. But I did know how to turn it into numbers and then work with it digitally. So my previous experience and my natural inclination to build things is I would build a model of this, build the actual device, and see if I could store the thing. So I used existing parts around the laboratory to pull together this very weird-looking prototype. And there are other elements to a camera, which, of course, is the lens system. But because you work at Kodak, it turned out our laboratory was right above the manufacturing line for the XL movie camera, which was an 8mm movie camera system that Kodak was producing at the time. And I saw that the image size of the CCD was smaller than that of a frame of Super 8. So if I could put that CCD somehow in the film plane of the optic systems of an XL movie camera, I wouldn't have to build any optics, which I was totally incapable of doing anyway.
Well, that's pretty convenient.
So it was convenient. So I literally went downstairs, and I can't remember if I stole or asked permission to do this, but I basically went to the used parts bin and pulled out an old XL55 movie camera, which was somehow broken, and brought it up, took it apart, and that's what I used for my optical assembly. So it goes back to the days of Brooklyn when I was tearing stuff apart and using the parts for other purposes, and that's exactly what I did here. So in a sense, I was doing what I naturally liked to do and normally did at that point in time. And yet I had access to a wider range of parts and a more sophisticated set of electronics. So I used that to pull together this prototype camera. And it took about a year or so to build the camera. And then I had this other problem of how am I going to view the image? I thought, why just measure it? It'd be great to view it. I mean, you get curious. What does it look like, right? And so I had to build a playback system, some sort of system that would turn it back into an image. And the only way to do that was you to do it electronically. I didn't know how to print anything. And so I went to my supervisor, Gareth Lloyd, who now knew I was trying to build this camera, and who was supportive of this crazy idea, okay? He was probably the only person I spoke to in management about what I was doing. Not because I was being deliberately hiding it. It's just because nobody really cared. And I wasn't sure it was going to work anyway. So why advertise if I was going to fail, right? So I would go to him periodically for reviews and say, oh, my camera's doing okay. And he would support that. So then I had to build this playback unit, as I mentioned, and that required more sophisticated electronics. I had to take these set of numbers, rearrange them back into the matrix, and then put them in a format that would be more compatible for a television set, then create a television signal from that still pattern and send it to a TV set. That was the idea.
And that probably wasn't so common at that stage either, right?
Oh,
because
well,
we didn't have PCs and
there were no
other
PCs,
gadgets, and of course,
everything.
First personal computers, did use a TV rather than a traditional monitor.
That's right.
But that just wasn't the norm either.
No, it wasn't. And so, in order to do this, as you mentioned, there were no PCs. There were microprocessor chips, and Kodak were trying to put some of these in their very early products. The first copiers we were making had the first microprocessors in them. And I happened sitting next to a guy who was working with those microprocessors. So I said to my boss, I said, and since this project was in no way sanctioned in the sense of there were no reports or reviews from management or how things were going. Nobody came and asked me how it was going. I would just, when I would visited with Gareth Lloyd, I would mention how this part of it was going. I was doing other things at the time as well. And so I asked him, I'd like to do a study of microprocessors. Well, that's within our charter. New electronics is applied to our product base. And I said, can I get a microprocessor development system? And he said, sure. That's a good idea, right? Well, I bought this system. It was an old Motorola 6800, I remember. And it had tremendous addressing capability, better than what Intel had for direct addressing, as I remember at the time.
And you needed to be able to address
all these chunks of memory.
Yeah.
And so this system came with a publicly verifiable bus, which allowed me to build custom boards that would fit into this thing. So I got this system, and we said, oh, we're going to do microprocessor research. It disappeared into our back lab, and it became our playback unit. Now, if I had gone in and said I wanted to buy it to build this playback unit, there's no way anybody would have given me the money to do that. So being creative with your requests is certainly a helper for an innovator, I guess. But in any case, we spend a long time doing that. And then it might surprise people to know that we worked on this for over a year. And we never saw anything. All we measured progress was by voltage measurements or waveforms on oscilloscopes. That was it. And we would do system by system by system. By the way, I have to mention that I was really helped by a technician who was working with me. His name was Jim Schickler. And he was a really, really innovative guy as well. And he and I were learning together all of this stuff. And so he was a tremendous help. We worked shoulder to shoulder for over a year in the lab. And we would constantly fix things all the time. Everything was breaking, or assumptions we had made were no longer relevant. And so So finally we got this thing to work together. And after all this time, you think we would know exactly what to do with it. It never occurred to us, what are we going to take a picture of? We were in a back lab, poorly lit, very disrupted place. And so this camera, which was an odd looking thing, which would unfold, and that's where we built everything. So there was no build a board here and then test it and then put it into the camera. It was built in the camera. The camera was the test bed. So it would unfold, and when I could work on it, it would work in that position. But finally, when you wanted to use it, you would fold it all up, and it became about the size of a toaster, contraption with a big little blue box on top that held the optics and things. And so I picked this thing up, and I walked out and took a picture of a young lab technician. Her name was Joy Marshall. She was sitting at a teletype just down the hallway. And she knew us as the weird guys at the end of the hallway. Nobody knew what the hell they were doing. And so took a head and shoulder shot of her. And I remember this because I like to tell this story because it's so true of innovation. What would happen is you would capture an image, 50 millisecond exposure time, 20th of a second, the image would be captured and read into the DRAM. And then from there, from the DRAM, it would be sent to the magnetic tape. It took about 23 seconds to do that. So when I saw the tape started to move, I knew that I had captured the image. That was my feedback, right? And so the tape started to move after I took her picture. I walked back to the laboratory. After 23 seconds, you pop the tape out, put it into this playback unit I just described. It would read the tape back in. And then we had to do image manipulation, which was all hand-coded with assembly language. It was awful hard to do that. And then up would pop the image. And what popped up was you could see she had dark hair, a white background. You could see the outline of her face, her hair, but her face was complete static. Couldn't totally recognize it. And so Jim and I were really happy what we saw. We knew 1,000 reasons why you might not see anything, right? I mean, we knew
so many things that can go wrong.
So many things. You just see nothing, Yeah.
Yeah.
We've never actually tested the whole system together.
Yeah.
So we're looking at this, and I remember standing there, staring at the screen, saying, wow, so much is working. This is fantastic. And Jim was just as excited. Well, Joy had followed us back because she was curious as to what this thing was. And she was standing in the doorway, and we turned around, we saw her, and she looked at us, and she said, it needs work. Turned around, and she walked out. And what I had happened is when I designed the playback unit, I had reversed the order of the bits in my mind so that if it was all ones or all zeros, each pixel, it didn't make any difference. And so that's why the black hair and the white background were viewable. But of course, any of the continuous tones, it was in between. It was each pixel was digitized to a 4-bit word, was reversed. And it took us about an hour to figure that out. And once I did that, I changed some wires because that was easier to do than changing the code. Yeah. Then the picture came through. And that was taken in early December of 1975. So that was the first digital snapshot.
Wow, that's really cool. And how long was it before this started seeing the light of day in terms of being shown around within Kodak? Was there much more that you needed to do before you could show it off?
Well, once we had taken pictures, I went to my supervisor, Gareth, and I said, hey, the camera's working. And I remember his comment was, oh, we'll have to bring people into the lab to show them. And I said, no, it's portable. He didn't even know I was building a portable device. I mean, that's how much attention was paid to this. Right?
Yeah. That's incredible.
And so I said, no, I can bring it around.
So after a year's work, they
hadn't gone into the lab to look at it.
He hadn't seen what you
or
were
if
doing.
even if he had, he would have seen something that was unfolded, so it didn't look like a portable device.
Yeah.
So he set up a series of meetings, and whenever you're inside a big corporation like that, what you typically do is show it to your boss, and then he gets comfortable with his peers, and then they invite their bosses, and you go up the chain. It's very typical, and that's what happened here. We showed it in a conference room that was in our laboratory. It was about a 40-foot walk from my lab, and they would go into the conference room, and we invited them to say we're going to show them. You know what I called it? I called it an example of filmless photography, which was a really poor choice of titles, given the audience I was going to show it to. But that's what it was to me. I never really thought about the ramifications of it. I just simply said, I'm not using film.
Yeah,
And
I
so,
guess the ramification is pretty big when
well,
the very, very large
it,
majority of...
it became evident that I had sort of missed that part of it when my thinking, because as I started to show it to groups, and my demonstration was quite simple.
Yeah.
I would walk in with the camera in my hand. Again, it's about the size of a toaster. I could look to the viewfinder. I would take a picture of the person who was sitting on the front side on the right. Whoever was sitting there, I would take a head and shoulder shot of them. And then my tape would start to move, as I described before, and I would use that time to describe what this thing was and what it had just done, and to cleverly hide the 23 seconds it was going to take me in order to be able to take the next picture. And then I would go to the person on the left, and I would take their head and shoulder shot. Then I would put the camera down on the table, one, because it weighed 8.5 pounds, and the second thing is they wanted to look at it. And then I would pop the tape out, hand it to Jim, who had brought the playback unit. We had put it on a cart and put it in the back of the room with the TV set there. Plug it in, and then about 30 seconds later, up would pop the first picture. So you got to understand, I was taking pictures in Eastman Kodak Company of Eastman Kodak managers. In 1976, I wasn't using any film. I wasn't using any paper. Okay. And so it was a very interesting demonstration.
Yeah, yeah. What sort of responses did you get, and did they line up with what you were expecting? Did you know what to expect?
Well, I was very technically oriented, and so I thought that the conversation would center around how I did this. I had pulled all of these different types of technologies, used them in unconventional ways to make this unconventional thing, right? So I was very proud of this device. We got it to work. So I thought they'd ask me how it worked. No, they asked me why I thought this was a good idea. All right. And I wasn't prepared for that. Why would anybody want to look at their pictures on a television set? What would an electronic photo album look like anyway? These microprocessors, what has that got to do with anything? What about the photo chain? Where's the photo chain going to fit into this? Are they going to be photo dealers? All right. And how long will it take for this technology to get to the point where it might be available for the consumer? Because that's what I was suggesting. This was going to be a consumer device. I didn't know exactly how long. I didn't really thought about it. I simply thought this concept, if put into a model, it was demonstrated. This thing actually worked. Available light would take pictures. They were quite recognizable, black and white only, but it was quite recognizable. And so I was challenged a lot. But both in terms of certainly the why, and then also the how. Would it ever get good enough? Would people ever accept that? Would looking pictures on television sets? That's nuts, right? And so I was challenged by a number of questions. The one I got all the time is how long it was going to take. And so what I did was, because it was a completely digital system, and it was completely digital from the output of the CCD all the way to when it went to the TV set, was all digital. I said I could maybe use Moore's Law to anticipate. So I didn't know what it would take to make a good picture. So I called up the people in the corporate research laboratories. And I asked them, and they said, I asked them, how many pixels would I need in order to make a consumer acceptable image? They were looking at this at the research laboratory, so they knew the answer. 1 million pixels, 2 million if you want color. That was their answer. So I said, okay, colors, we're going to have to do color at some point. I had no idea how to do that, but luckily people in the research lab did. So I used Moore's Law, and I estimated between 15 and 20 years. So that's what I told them. I said 15 or 20 years, this would probably be viable for consumers. And it turned out that prediction was actually pretty much on the mark for all the wrong reasons. I have to say so many assumptions in that estimate that they were all wrong, but they were wrong in different directions, so they averaged out to be right.
Yeah, and ended up landing.
And we launched our first consumer camera 18 years later. So it was, but when you're talking to managers and you're talking about 20 years, people, there's less urgency in their voice,
That's a very challenging thing. How old were you at this stage? You'd only been at the company then.
26.
Right.
I was standing there at 26 years old.
Yeah.
So I was not qualified to do this. I wasn't.
And you were getting asked questions that were, really you were really in the deep end. Those weren't things that you had studied or probably been your primary thing to think about.
Right.
So it's quite an interesting dilemma. Was there anyone else that was able to assist from that perspective? Was there anyone else on the that was able to back you up and support you from that perspective?
I will tell you, ever since I did that project in 1975, I worked in digital imaging inside of Kodak. I was never able to talk about any of this work largely, but we worked continuously in digital imaging. I became fascinated by this because I must tell you that I was challenged a lot by both marketing, business, even technical, although there was a lot of technical support. Techies love new stuff, and they were very supportive. There was never, usually the pushback I didn't get was from technical people. There was always, in terms of forecasting how fast we would get there was always the issue, or if we would get there, or how we would get there, right? That was always an issue. And that debate took place for many decades after that. But they never convinced me that it was impossible to do. And the reason is yes, in where I was in the room. I was in the room, and if somebody was arguing with me about whether this would work or not, or be viable or something, occasionally that person would be arguing with me, and their picture would be staring at me from the picture I just took. I knew it would work. It didn't look that great now, but I was just me and Jim Schickler and a pair of pliers in the back lab, right? So I think that no one could prove to me it wouldn't work. They would argue about how long it would take. So I did get a lot of support from the technical community. And also there was a lot of argument. There were many different business units that came and visited here. It wasn't just the consumer people. It was the professional people. It was the people who were interested in microfilm. I remember one incident where I showed it to a group of managers. This took place all throughout the spring and summer of 1976. And one fella looked at this and he stood up. He was from the microfilm area. And he took out a check and he slammed it on the table and he said, "Take a picture of that." So I did. Right there. No preparation, no excuse. I took a picture of the check, put it up on the TV screen. He walks up to the TV screen and he said, "Not enough resolution." He says, "If we get more resolution, this works better than anything I've seen anywhere else." So these guys were looking for solutions. That thing itself was not going to do anything. But if a certain attribute of what I was showing would get better, they could see a pathway to being useful. He was interested in black and white imaging, high resolution of checks, right? And so that's what I saw. The different people from different marketing or businesses or parts of the economic spectrum would look at a certain attribute of it and say, if that got better, I might see a pathway.
Right. So you were usually presenting to people that were very interested in how it would serve the needs of their particular division, and very interested in the I guess the financial outcomes from the technology.
Yeah, they were very interested in it future wise. So I will tell you, the people inside of Kodak, they got it. I mean, I was challenged right away. There's no film here. Why is this a good thing, right? And they got that right away, right? I wasn't prepared for how to deal with it, right? But they got it. And no one ever stopped me. Right after this, I started building another camera with a higher resolution CCD. I never built a portable camera because it got so big, and I worked, like I mentioned before, continuously in digital imaging my whole career. So technically, there was a lot of support for this, and it was very interesting to a lot of people. I would say the marketing arm was less enthusiastic about publicly talking about this stuff, and certainly management didn't want to talk about it.
How high up within management did this innovation go? Do you think in those first year or two?
I remember it was quite clear. We would go up. Different people would come in and they were higher managers as we went through the summer. And I must say that I give a lot of credit to Gareth Lloyd, who was my supervisor. He always let me present this and show it. Normally in a hierarchical organization, your boss would take over or their boss would take over because they were showing something quite disruptive and controversial. and they have relationships and organizational things to maintain. But they never did. They let me present it. Now, maybe you could also look at it as I've got nothing to lose and they do. I don't know. But so we went pretty high up. The highest we showed it to was the head of the apparatus division laboratory. And we showed it to him in a private showing. He came in, the head of the whole apparatus division. So he was a VP of the company in charge of all the equipment, cameras, everything that was made and designed by Kodak manufacturing.
So only a step or so down from the.
He was a step down from the CEO and the upper management of the company. We showed it to him, and then that was as high as it went. And then I heard later that the CEO of the company, who I've never met, never seen in person, right, who worked at Kodak office, another part of the city, had heard about it and asked if he should see it. And the answer was no. And I was a little disappointed. One, I would have loved to have met the CEO of Kodak,
of course.
but why wouldn't they want to show that? And only, after you get a little older, do you realize that here I was, this 26-year-old kid walking around. I've got no right to be done any of this stuff, to taking pictures without film, displaying them without paper, in available light, and it worked. And so think of all the questions that generates from a CEO's perspective of this company, right? For over 100-year history of photographic technology. And so if you were a manager of that person, or the manager above the manager of that person, that CEO is likely to turn to you and ask you that question. They probably wouldn't ask me. And they didn't have answers. And so I think what happened is that there was just too many questions they didn't have answers to, and they knew the CEO would ask them. And so they just wanted to avoid the issue. That's what I think. I was disappointed for the reason of just not meeting the guy, as opposed to any kind of a bigger failure or anything. I was a little disappointed with that. So, I was very happy with the technical work. I was allowed to continue with my technical work. I actually, from an organizational point of view, I went down in the organization after I presented the camera. I got a boss that was between me and my supervisor.
Okay.
Yeah, that actually organizationally happened. Luckily, it was a really nice guy, and I learned a lot from him, and so I didn't mind it at all. In fact, I remember telling my supervisor, he came in and he was sort of like trying to explain this situation to me. Like, what you did was like really, really cool. We have to give you a boss. And so, it's like, we're moving you down in the organization because you did so well. And, but I looked at it as, well, if what I did was so important that they need somebody really looking after this and they don't trust me, that's a good thing. It's more people are interested in it. You understand, up to this point, nobody cared. I couldn't get anybody to come into that laboratory, right? So that's what happened. But I was allowed to continue my technical work, which was my primary interest. And then, of course, I learned more about CCDs, digitization, and through the 80s, we learned about image compression, image manipulation. And
so, what were the steps in between? What was the next camera you built? What did that consist of? And how did you get from I guess what was a 10,000 pixel device, which is a pretty small fraction of a megapixel, isn't it?
Yeah, it'd be a thumbnail today, a really poor thumbnail, right? That's what it would be.
Where did you step to from there, and how long did it take to produce the next one? Because you obviously had some very good expertise under your belt of all the bits and pieces of how you put this thing together. What was the next challenge, I suppose, in terms of building another one?
Well, in the course of all those demonstrations, I really did get some good conversation, some challenges. I couldn't really deal with some of the problems about people never accepting this, but I looked at the technical challenges that were presented, and I, in my mind, broke up the whole problem of digital photography into three parts. One was the sensor itself, and the sensor had to get obviously a lot better. We had to deal with color, resolution had to go up, speed, everything had to get better. I really couldn't do anything about that. Luckily, Kodak could. And luckily, at the same time, there were people doing some really innovative thinking about how to get color out of a monochromatic mosaic of pixels. And that was a fellow named Bryce Beyer proposed the Beyer array, which of course is quite famous. And he proposed a micro lens array of a pattern of filters that would be put on top of these devices, and it would do color. And he had a very significant patent on that. I had a chance to meet Bryce Beyer once. We casually talked in his office at KRL, and it was looking back on it, it was quite a moment. At the time, it was just I was just meeting this really interesting guy. Had an interesting idea,
KRL, Kodak Research
Research Laboratory. Yeah, there was corporate research laboratories. I was in an applied research laboratory in a physically different place. The corporate research laboratories was a much bigger area. There were hundreds and hundreds of people working in a lot of different disciplines. And this is where they did develop the electronic imaging started there, as well as obviously all of this silver halide emulsion technology and stuff. Research was done there as well. So that was a well-funded, very high-end area. And so they were looking at CCDs, making them, because Kodak knew well ahead of time that the research, what you needed in order for this to ever be viable, that is to replace photography. You can argue whether you want to do that or not, but if you were going to do that, it had to be much higher resolution, and you had to be able to do it in really good color, because film is really good.
Yes.
And we knew how good film was, and you can't displace a technology just because it's cool and neat with something that does the primary job in a worse way, right, of taking good high-quality pictures. So we knew, as opposed to throughout the 1980s, a lot of the video companies, Sony and Canon, the electronics companies, were proposing solutions that were based on their video mindset. Every company has a mindset. They sort of use the tools and technology they have to solve every problem, right?
Yeah.
And they saw it as a video problem. And we said, no, it's not a video problem, because video is never going to be good enough. It's a computer problem. We knew it was going to center around the computer, not the television set. And so most of the work went to, starting in the early 80s, very high resolution CCDs. Now, Kodak never publicly talked about any of this work until 1986, many years later. This is 10 years after all my work was done. They were working on this. They put the Beyer filter array on top of a CCD that they made. And they were just prototyping them at the time, never announcing any of this stuff. But because the new competitors, the Sonys and Canons, were going to electronic shows and saying, hey, we're going to do all of this stuff, we didn't want to lose the confidence that the marketplace had in us in terms of our expertise in imaging and being able to project where it was going to go. So I remember they demonstrated that publicly for the first time in 1986 at a show. I can't remember the name of the show. And it just demonstrated the image quality that they could get out of one of these. And it blew everything else away in the show. I mean, it really was really good. And what we did that to really sort of calm the expectations of the public down. We wanted people to trust Kodak and say, we'll tell you when it's ready. We know what's going on. We're not talking about it much. So that was the first time it was anything was shown. It was a really nice demonstration. But this work continued throughout the 1980s, and I continued working on this. I broke the problem up, as mentioned before, into three areas in my mind. One was the CCDs that was being addressed by Kodak. One was computation, speed of computation. Those were microprocessors, and how fast we could manipulate digital data. Okay, and that was being done by microprocessor. There were new microprocessors coming out all the time, right? And also dedicated DSP chips were starting to come out. So this was
a digital signal processing.
Digital signal processing.
And this was key, wasn't it? Because initially you were dealing with in the scheme of things, not a huge amount of data. But as soon as you start dealing with higher and higher resolution images, you've got exponential challenges in terms of how you manage that and deal with it and store it and
exactly.
So on.
When we were going through the 80s, everything was getting worse.
Yeah.
You understand? We were projecting everything was getting worse because we wanted to deal with more and more data at higher and higher speeds, okay, and more complicated computations. So the problem was getting worse. The solutions were coming along, but the problem we knew was really bad, right? And then there was storing the image. How can you store a digital image that's as convenient as film? Remember, you're always comparing to the existing technology. So we needed some sort of solid state film. And I saw that as a problem I could sort of look at. And I started to look at that in the early 80s. I started looking at electric alterable read-only memories. I remember buying some experimental ones from General Instruments. I remember going to a talk at MIT, and I remember this because, again, I'm just a relatively young researcher, really curious about stuff. And the guy started talking about this technology, so I asked a question. And they got so upset with the question that, in terms of the ability for these things to continuously store these things, you could write to them, but they would sort of wear out after a while.
Right, yeah.
And so I simply said, how about that? Have you noticed any degradation in the, and he sort of answered the question somewhat. And then when I walked out early to go to lunch early, and 3 researchers chased me down in the parking lot and asked me how I knew to ask that question and what I was doing. What did I know? Right. And of course, I said, well, I'd done some experiments. Why are you doing experiments? Of course, I couldn't talk so much about what my reason was.
Yes.
This was just a device thing. But I was piecing this together in terms of this, learning about this stuff. And then in the mid-'80s, we got dealing with image compression, which is another technological hurdle. Can you eliminate the redundancy in an image? Well, yes, you can. People know about image compression, but it was done on very high-powered computers in research laboratories. So I thought, can we get these out of the lab and into an actual device, and how good does it really do? Because it had to be really good. You couldn't see the difference. And when we say you can't see the difference, and you're at Eastman Kodak Company, you can't see the difference, okay? And so luckily, again, Kodak has such a collection of talent in all of these areas. Best place in the world to work for doing imaging. Dr. Majid Rabbani, I went to him. He was an image compression expert. And I asked him which image compression algorithm of the more than 20 that were being bandied about in the mid-'80s as to what would be the best way to handle a continuous tone image like that. And he said, yes, well, use discrete cosine transform, which was a transform way to do this. And he said, that's the best way to decorrelate the image. So when I looked at the technology required for that, I said, do you have anything easier? Right? It was really computationally difficult. And I remember him saying, well, that's not really my problem. You asked me which is the best way to do it. Let me help you with this, right? And so we formed a project, and we were doing this little image transceiver, a device about the size of old VCR. Then all it would be capture one still image, and it would store it, a color image, store it, and then we would do image compression on it. Squeeze all of the redundancy out of it, send it over a telephone line, and then using identical unit reconstruct it. And you couldn't tell the difference between what was reconstructed at the other end and this one, and to do it in under a minute. Okay,
that's fast.
That was very fast, and it was very challenging. And we worked with the corporate research labs and Majid Rabbani's team using the algorithms that we had to create for this human visual response, and we were actually doing this really well, so that we could not see the difference. Okay. Now the problem was speed, and I remember we were using Texas Instruments' fastest chip, but we couldn't get it to run fast enough because the tools they gave us required, to compile this stuff to make this code work. They couldn't run any faster. We had to get it to run faster. And I remember flying down to Texas Instruments, to Houston. And I wanted to find the guys who did this chip, but how do you go? I can't tell them why I'm coming, right? So I told them I was going to give them a talk on image compression. They got to understand, I'm totally unqualified to give a talk on image compression. I'm working with Majid Rabbani, who is eminently qualified to do this, but nobody's letting Majid out to talk about this kind of work. So Majid taught me enough, right, to that, and gave me some great samples of this. And I remember at the hotel when they picked me up, the fellow who picked me up was one of their researchers. He says, we have researchers that flew in from all over the world to hear your talk, are really interested in this image compression stuff. So I'm thinking, oh, I'm dead. They're gonna take me apart. But luckily, they had studied all the wrong algorithms. They had all studied what I would call, space domain algorithms, this was a transform algorithm. You transformed it into a different domain and then you did it. And so luckily they hadn't studied that. And so I explained what we'd done and passed around the pictures, and they were extremely impressed. Kodak's really good at pictures. So we did before and after prints, and you couldn't tell the difference. And these guys couldn't believe. We said this was a compression rate of, we took out 80% of the stored bits, and they're looking at it. They couldn't believe we were doing this, right? And so I'm not there to impress them with our algorithm. I'm there to figure out how to do it faster. So I remember talking to them, and I put up the kernel. That was the DCT kernel there that we were doing this, the actual transform thing that would be repeated throughout the image. So it's just the basic algorithm. And I said, we're trying to do this with your latest chip. So it's kind of their problem, right? I said, you're using your latest chip, but we just can't get it to run fast enough. Does anybody know anything about this chip? And thank goodness some guy in the back raises his hand. He says, yeah, that's my chip. I designed it. So then I forgot about everybody else in the room. I walked down the hall, up down the column to get to the seat. And I said, how fast can you do that? And he said, oh, I can make it go way faster. The tools we give you have all these checks in it. You don't really need to do all of those things. And I literally, by the end of the day, we had him sign a non-disclosure agreement. We gave him a test case. And I was only like a week later, hand-coded came back. This thing, it screamed, right?
Wow.
Really fast. So that's what we did, and we put that in the algorithm. Then the product was actually offered for sale. It was offered for sale in 1987. It was called the Still Video SV9600 transceiver. And quite frankly, I didn't know who would buy this thing. I mean, maybe law enforcement, maybe real estate people or something that wanted to get an image back to their home office or something. But it was awkward. You had to plug it in, sit on a table and everything.
Right. So this would capture a reasonable quality color image.
Yeah.
And then you could transfer it over a phone line.
Over a telephone line, anywhere in the world, under a minute, and it would look the same. That was what it did. Mm. So I was very happy because we actually got this technology to work. And I wasn't thinking about the transceiver. I'm thinking about putting it in a camera. But that's the next step. You don't really say that when you're doing this. You just say, that's what we're thinking, right? So, and it turns out then that it was launched in the company because it wasn't a camera. They allowed it to go out. And in fact, I don't think they even noticed it went out. And our business unit knew it was going out there, but nobody really paid much attention to it. I don't know how many we sold. It couldn't have been more than 100. I don't know. Anyway, it turns out that CBS News had bought one of these, and Tiananmen Square happened in 1989. And that became a very significant political event. And the government shut off all of the outlets for getting pictures out, but they didn't know this existed. CBS News had it. They were the only people that had it. So they were getting pictures out. So they were ecstatic with this. They were the only people getting pictures out. A lot of the famous images you saw from there came through this. And so they got so excited they wanted to do a television story about it. Now here's an interesting point. We're in 1989. Digital imaging hasn't happened yet. People are talking about the possibility of cameras, but nobody's really got one. And all of a sudden, CBS News comes on and says, we want to do a special story about your device. So a major news organization wants to do a free story about your cool technology. They go to Kodak, and Kodak says, oh, no, don't do that.
So they were going to
promoting this electronic still imaging.
Right.
All we thought about, or our marketing guys were thinking, well, you're really going to create a lot of questions for our existing customers of film.
Right.
And we don't want to answer them, so don't do the story.
So it could have given you huge credibility.
We didn't want that.
The leaders in this space.
We didn't want that. Wow. Well, it turns out that, what happened is we had a very innovative leader. His name was Brad Paxson. He was charged of the electronic photography division, the division that was responsible for generating this and some other technological projects along the same line. And he knew management, and he worked with them, and he came up with an agreement, said, well, we'll do the story, but we won't mention the word Kodak, won't say the name of the product. So they agreed to that. And then Brad said, I wouldn't mind it if you showed the product. And then when the product worked, the splash screen said Kodak SV9600 on it. So it was very clear what the product was. So in a sense, we sort of skirted the rules. And the story was done. And I remember seeing that story, standing in the lab watching it and saying, oh my goodness, I I never saw anything that we had done actually make an impact in the world. It was all the technology, but here it was, and they were, it was doing some significant good for people in terms of information. So that was sort of the first time any of our work actually saw the light of day. But it was really the technical underpinnings for the next camera we built, which was the eCam, which was built in 1989. So most of our work was not made public at this time in the late 80s. But there was a number of groups at Kodak starting up, looking at building cameras using the CCDs that Kodak was developing. Again, not public with all of this stuff. And one of the cameras was one that I was working on with a master camera designer. His name was Bob Hills. And we decided we'd try to use some camera bodies that we were working with another company and make digital cameras that look like real cameras. Bob was a real camera designer, so he wasn't going to make any of these crazy looking cameras. He was going to make one that looked just like a DSLR. And so we took that technology that we had done for the transceiver, miniaturized it as best we could, put it in, it took the CCD that was KRL was making, and we put it into a camera. And
so this was into a conventional SLR camera body,
about the size of a Nikon DSLR today.
Right. So,
and we wanted to see if we had to hand build them, and we were trying to demonstrate that we could create an architecture that would take the images out of a CCD, put them in a burst mode storage, and then do image compression on them very quickly, and then store them to a memory card. So to have a memory card in it as well. So we were taking all of this stuff and putting it into one package that looked like a real camera.
Right.
And so we got this to work. They were operational in 1989. I think we made about 6 of them or so. And I remember at that time, it was clear to me then that all the questions that we have been wrestling with for the previous 14, 15 years were being answered, either by work being done directly at Kodak or by industry standards that were evolving or parts that were becoming available that would allow you to configure a device like this. We know because we built one, right? And when we showed this to management, we went to marketing in the professional, Kodak Professional. We showed them the camera, demonstrated the camera. Really good pictures, 1.5 megapixels color. It was nice. Memory cards. We asked them, could they sell a camera like this? And the answer was clear. Yes, we can, but we won't if it comes to the expense of one film camera. Why would we? I mean, it's a rational response because this camera cost a lot of money. It was complicated, probably unreliable when it would be manufactured. You'd have to do a massive training part, and there's no recurring revenue stream. So why would I as a business do this? Right? So it was at this point in my career that became clear to me we no longer were dealing with technical obstacles. We were dealing with business model obstacles and to some extent cultural obstacles because people were uncomfortable with some of the technological nuances of digital photography. Image compression was a cultural problem. As much as we technically could show that the mean square error between compressed and uncompressed images was, in the original and the compressed images, was pretty small. It's possible for you to find an artifact somewhere in the image, maybe, on some images, on sometimes. That was something that they never dealt with. When you dealt with film, your negative was it. There was no, everything that was originally captured is there. When you explain image compression to the early photographers, like we're going to throw away 80% of the bits you just captured for your original, that was an emotionally event for them, right? So our early cameras, digital cameras, had to have switches on them to turn image compression off in case you wanted to do real photography. So this is just an example of the cultural challenges associated with a technological solution, right? But luckily, I got kind of discouraged at that point. I had been working on this for 15 years. The technical answer was before us. I was holding it in my hand with the eCam, and the answer was no. And so I said, man, I don't want to work with these guys anymore. So I went off and did printing. because I could make digital printing. Was image processing still the same for me? And they were doing thermal printing. So I went off to do thermal printing, and we were developing a printer that eventually turned into the kiosks that Kodak was actually quite successful at. So, and I knew the reason, my justification for moving from cameras to printers was simple. They had invested $60 million in gravure presses out in Colorado to make this thermal material. They're serious about this business. For cameras, they weren't serious, as far as I could tell.
Right, and they could see from the printing perspective how that was going to help the business in terms of
there was the return.
revenue.
It was a business model they were used to thinking about, selling materials, right, consumables. So I went off there, but luckily, and Bob Hills went off making regular cameras again, right? But luckily there was a team of people. Some of the people from our eCam team joined a team under a fellow named Jim McGarvey, and he was building cameras about the same time as well, some experimental cameras, and they found a market with the government, who were the only people who could afford these cameras and would be willing to deal with all of the idiosyncrasies of these early cameras to gain a few benefits like instant manipulation or image transmission. Right? So we started making cameras for them. Jim's team started doing that. And of course, you learn about what the customer needs and wants. We built some flexible platforms. Then they came out with some smaller cameras. Okay. It was called the Kodak Professional. I think it was in 1992. And it was a Nikon body camera that had been gutted and the electronics put in it, and then a tethered electronics pack that they would carry around. So inconvenient, $25,000, but it could do something that a certain segment of photographers wanted, which was photojournalists. They'd like to be able to see the image they just took, and they would like to be able to transmit it back to their newspaper right away. That's kind of cool. So all the drawbacks in terms of, something you take for granted today, but all the drawbacks associated with the big camera, complicated system, they could live with that to get this one feature, right? And that's how you make progress with a new disruption like that. And then, of course, that spread to desktop publishing and all the rest. And so throughout the early 90s, Kodak had a very aggressive and successful professional DSLR business. We had a marketing arm that was selling these things. We weren't making lots of money, but we were out there with it. And then we moved to the consumer space. Kodak did the Apple QuickTake 100. I was marketed by Apple name on it. Kodak didn't appear anywhere, but we were the guys that designed and built the camera because we knew how to do it. And Kodak and Apple was very interested in getting the on-ramp onto their new computer. They were the imaging computer of note in the mid-90s, and they needed an accessory to get in there, to get the images in there.
Yeah.
So we built it, and all kinds of odd stories about these kinds of things where the camera, if you ever look at that camera, it looks like a binocular, not like a camera. That was deliberate because we would build a camera. We didn't want it to look like a camera. Again, dealing with some of the cultural challenges of this. Our name wasn't on it, right? And we had no channels to market it anyway. So we were pushing the technology, we were commercializing the technology, but wasn't widely recognized it was us. Remember, the cameras we were selling in the professional space had Nikon written on them.
Yes.
I mean, it was a Kodak camera, but Nikon was still on the camera. So it wasn't quite as visible, right? But both professional and the consumer started up in the early 90s was the professional, and the mid to late 90s was the consumer space. And that's when it started to take off. Kodak started making cameras under their own name. I think it was in 96 or so, with the first consumer camera. First megapixel camera, I think, was in 97 or 98. And that was kind of the defining design, okay? The dominant design, where you had in a camera, you had all the storage, the sensor of the storage, you had a display on the back, you could review the images. All of the elements you take for granted today in a digital camera first appeared in cameras around 1997, 98, something like that.
Now, looking back at this period, which spanned 20 plus years, what were the big lessons that you learned around innovation and invention and being a successful innovator? What are the things that you really learned and that you would share with people today through the various things that you're involved in, sort of teaching the next generation about innovation? I mean, it seems as though some of the greatest innovations come about maybe not quite by accident, but certainly, the path at the beginning through to what the results are often isn't particularly clear to a lot of those involved.
Well, the story of the evolution of digital photography took over 30 years, okay, most of my working life. And so you learn some things. It's not just about technology, it's about people, it's about organizations, it's about the human ability to absorb change, right? So let me list out some of the things that I think any innovator should be aware of or be conscious of that might not ordinarily jump to right away, especially if you're driving a hard technological change. Culture, corporate culture. That is a really, really powerful force. You may think you have a lot of data to sort of convince somebody, but when you're dealing with a cultural change, you really have to pay attention to it. And I found that if you use the culture, don't fight it. I'll give you an example. When I did this inadvertently, by the way. When I did the first prototype, I could determine how many pictures I put on each individual cassette tape. And I was very excited because I could put hundreds of pictures on the tape. I thought this was so cool. But I decided to set the bit rate or the bit density to 30 images on a tape, halfway between 24 and 36. I did that kind of deliberately because that sort of made it look like a camera. It was the same mindset of storing about that many numbers. Could I store hundreds on there? Yeah. You know what that would have done? Created another distance to the concept. That was not necessary. It was already distant enough. So pick your battles and use the culture. Don't fight it. Okay, that's one thing I learned. Second thing is public relations. When you're inside an organization, as a technologist, I didn't really pay attention so much to public relations. But the way you present things, okay, calling that movie filmless photography, that was kind of dumb. I mean, that sort of puts an alienation right away, right? I wasn't trying to take away anything. I was trying to add to the conversation, right? But people somehow look at you're taking something away. And so pay attention to that. The way you speak to people, the way you present these things, okay? You have to be persuasive. And technical people don't spend a lot of time being persuasive, right? And they almost have a disdain for it. But in the end, when you're pushing a technology, you don't have enough data, especially at the early phases, to convince them with a graph or a data result, right? You don't have enough data. So what do you have to do? You have to appeal to their hopes and dreams, bring them in, make them want to believe with you. I know it's kind of weird, but it's true because digital photography for over 20 years was a distant idea. And you either believed it would happen or you didn't want it to happen. But you talk about the advantages of it, taking down it. And all those advantages that we talked about turned out to be true 10 times what we thought. Do you think I ever thought that cameras would get small enough to fit inside a little cell phone that fits in everybody's pocket everywhere in the world today? No. I never thought about that. I thought about, how I described the early cameras? Because I had to use analogies in my presentations. Because digital calculators were just coming out in 76, I said, think about it as a calculator with a lens. That's the way I described it, right? I thought it's digital, calculators are digital, and it's a consumer product. There weren't many consumer products.
So something people could relate to.
But some of people relate to. And that's all about the persuasion part of it, right? So it isn't necessarily technically rigorous, but it's emotionally really powerful. And so, yeah, I know engineers don't like to talk about emotion, but I got to tell you, it's when you're trying to convince people to change, that's where it happens. So that's kind of what I learned. There's probably other things I could go on with, but those are the ones that come to mind right now.
Mm. Now, looking at the process of disruption, and of course, Kodak was a company that made incredible profits over a very long period of time, generated a lot of revenue from what in itself was a very powerful disruptor with what George Eastman put together with this making photography something that was simple and easy and accessible to a really broad audience. But because before then, to take a photo wasn't something that a normal person would do. There was a lot of complexity to it, but he made it into something that any most families could have a camera and go and get varying shots processed without a huge expense. So the history was that of being an innovative and a disruptive company, but then with digital photography, this was something that was really going to take away everything that had really led to the success of Kodak, certainly from that sort of profitability perspective, unless there was a way in which Kodak could monetize digital photography to an incredible extent. And I guess looking back, there's probably a number of different perspectives. But what are the things that have sort of stood out for you, over that period, and what do you think could have been done, better in hindsight from Kodak's perspective, and how could that have happened? Because there are so many challenges from a cultural perspective, from a I guess that loss of revenue perspective. So you had all sorts of people that would have been motivated on profitability, and the move to digital was something that was going to take a lot out of the lot of sales away, I suppose.
Well, it's kind of a tough question to answer. Let me start off with, just from my perspective, nobody has more respect for photographic film than me. You really gain respect when you're dealing with something trying to disrupt it. Think about what George Eastman did. He came up with flexible film, and then eventually turned into a color form of photography. And that little piece of film that's on a roll that costs almost nothing to make in mass production after you've made the investment. And you can put it in any camera in the world. Have it sit there for any length of time you want. Then do a millisecond exposure, a couple of millisecond exposure, and then have it stay there in the camera for as long as you want. Then have it taken out and developed by someone else anywhere in the world, and then have that same piece of film used to print it. Well, there is nothing in the electronic digital imaging train that's nearly as elegant as that. I mean, it's amazing, the technology. So I start off with a base of ultimate respect for the technology associated with film, and also with the business model that was created by George Eastman when he democratized photography in the late 1800s. So I like to believe that if George Eastman were around today, he would have been a big champion of digital imaging, because he wasn't a chemist by training. He was an accountant. He used the technology that was available to him to solve the problem he wanted to solve, which was to make photography available to everyone, right? As easy to use as a pencil, as he used to say, right? Well, if he were around today, I think he would have looked at digital and said, yeah, not only does it allow it to be used today, but also can be made even smaller in lower power. And so he would have been a big champion of it. So the challenge that we faced at Kodak wasn't that we didn't want to do this, okay? Kodak did tons of research into this in the mid-'80s and the 90s, created an incredible portfolio of intellectual property that has been licensed by just every digital camera manufacturer and cell phone camera manufacturer in the world today. So that wasn't the issue. The issue was, how do we find a business model that is comparable to what we had with film and paper? And that became very difficult to do and became impossible.
And that's I think the challenge that so many industries and businesses have had is, how do they get from an old way to a new way as technology facilitates all sorts of innovations that.
And doesn't make the investment that they've already made in their infrastructure. Like Kodak had an enormous investment in making film. Hardly anybody, looking over the last 150 years, how many people successfully commercialize photographic film? A handful. That's it. Okay. Very difficult to do. Extremely high investment, right? So once you've made that investment, you want to utilize it. That's perfectly understandable. But then new technology comes along and displaces it. And that happens in almost every industry, right? You sort of have to get to a point where you just have to say, all right, the investment we made is done. And we have to move on to new investments. And if you can do that in a timely manner, you can take the profits you're making off of the old and apply it to the new. The problem with it is that you have to do it in a time frame that's awkward, because you're doing quite well when you're making the money. The transition hasn't happened. And yet you have to voluntarily cannibalize yourself or sub-optimize that return to take that money and put it into something that isn't going to make a return for a while. And it's doubly difficult for publicly held companies for the obvious need of satisfying the shareholder desire for constant dividends. So I think that's a real challenge. And that's why you see most of the innovation taking place with startups. They don't have dividends.
Yeah, and you look at the executives of large organizations, and they're generally being rewarded based on the last quarter, not what's being invested into what can be done in 1 year, 2 years, 5 years, 10 years out, right? We haven't found sort of maybe the right models that encourage that within large organizations. And I guess you also got to deal with the challenges of what disruption brings to a culture, to a workforce. Kodak was a huge company. I mean, I think well over 100,000 staff.
Yes.
And digital would really shrink what the potential was for the business in terms of the number of people. So tremendous change to actually deal with, and in some ways it's you wonder what was there a possible path that was dramatically better than the path that the business took. And I mean, you'd probably have the best thoughts on that of anyone.
Well, I think I might have a set of thoughts, but I think there's a lot of different answers to that question. I will tell you though that of the CEOs that I personally knew, they were very smart guys. They got it. They saw it. They were dealing with an almost intractable problem. Not only do we have sunk costs and we're a publicly held company, I'm sure that if you talk to them, they probably would bemoan the amount of time they had to spend on getting a few more pennies on the dividend each quarter, as opposed to planning what to do 5 and 10 years down the road. I'm guessing that's the case. They were struggling with the cultural issues. Not everybody agreed with where we were going with this. Then there was, we had a business model that was compelling, that was very successful. So you come along and you want to get rid of it. Well, what are you going to replace it with, right? And it wasn't clear. Everything was changing too. So by the time you have to start to make the move, you have to be healthy when you start to make the move. And when you start to make that move, it doesn't look like you're doing a healthy thing, because you're not in the short term, but you are for the long term. And so I think if Kodak had made some significantly different decisions many years before the problems really started to occur, decade maybe before, they might have been more successful at doing it, but it would have been a wrenching cultural change. Certainly the commitment to our workforce. I mean, the people who developed and worked with film spent their life doing it. They were the only people that could do it. Okay. There's all kinds of stories about film builders when they left the company, all of a sudden they had to come back to fix problems, right? So the commitment you made to these people is enormous, right? They've dedicated their life to the company. And our company, set by the culture that was created by George Eastman, was one of, they had a commitment to their employees. And so they was very reluctant to make those changes. So it was all of these things, these cultural things, long-standing history in the technology, the significant commitment we had made to it, that inhibited us from making, radical changes. Plus, everything changed. Think about the internet. You probably would have had to react in the early 90s, late 80s even, to this in order to make a successful transition like that, to create the culture. Takes time to change culture. Where was the internet at that time? And all of a sudden the internet comes along and changes everything.
Mm.
Now, Kodak was one of the first people to do photo sites on the internet. But again, our mindset was put your pictures on the internet and then you can order prints. That was the mindset. See? So we're kind of stuck in the mindset. Here's the revenue model we have. But they weren't thinking about clicks. They weren't thinking about social networks because they weren't around. So you can sort of see the tidal wave that we were against it, that was against the company. And like I say, I think the people that worked at Kodak, the CEOs I know, the managers I know, the technologists I know, were really smart people. They got it. They just couldn't change the day.
So there's a concept that that businesses should disrupt themselves. The idea, makes sense, but
It's hard to do.
Realistically, it
really
seems that
is hard to do. That's why
there are a few that work out and manage how to do that. And it seems timing is everything.
timing is everything. Culture is everything. How you handle it. Remember, you're dealing with people. People can only change so fast, And when people say reinvent themselves, so what they sometimes indicate is, well, let's get rid of these people and get these new people. I'm reinventing myself. Well, the selves are changing, right? So there's that. You do have to reinvent yourself. It's changing all the time, and you may not be able to react fast enough, or if the change is big enough, you may not be able to change. Okay, and then there's a theory that corporations have a finite life. Where is it written in stone that every company has to exist forever, right? So there is that. The changes that Kodak dealt with were significant and they were huge, but it took a period of time. Think about the challenges faced by companies today, where I see major changes coming with artificial intelligence, virtual reality, automation beyond belief. That's happening very, very fast. That's going to affect our culture in ways that I think none of us can anticipate right now.
Mm. Did the idea of having futurists or really long-term thinkers exist during your time at Kodak? I mean, it seems now there's this futurist title is is reasonably common. When I meet these people, they I guess treated in different ways depending on the the organization that they were there within, and they have varying degrees of success, I suppose. Was that sort of concept something that you had? I mean, I guess it was the idea of that thinking ahead was something that you were involved in and lots of other people were involved in.
Well, I think the term futurist is kind of a new one for my lexicon. I hear and see these people, and I find them interesting to listen to. We had them back then. We had people that were strategic planners. That's probably the closest term I could come to. And they were smart people. They got it. They were I would say it's more of a practical implementation of a futurist. They had to deal, if you said something, you had to also back it up with some kind of a possibility of a plan, right? Of how to get there, right? Or what to do, right? You just couldn't say, hey, the world's going to change like this. Their job was to figure out how to get from today to then, right? And so that's what they did. We had a lot of predictions. We had external people come in and predict how long it was going to take for film to finally succumb to this electronic imaging and what we could do to either make it happen faster or make it happen slower. Both conversations took place. And we never could satisfactorily come up with the answer. Everybody guessed. I remember thinking the year 2000. I figured the year 2000 we'd be done. This was back in 1989.
Wow.
I was thinking that would probably be how long it would take before this really got practical. But I didn't anticipate the internet being as ubiquitous as it was. I certainly didn't anticipate cell phones. and the combination of that with cameras. So I mean, I can sit here and tell you I missed a lot of the stuff that makes up our world today. So I wouldn't be a good futurist, I guess. But we'd had people thinking about that, and we were wrong a lot of the time. Um, there's an old expression about engineers I love, and that is that engineers overestimate what they can do in 5 years and underestimate what they could do in 20. And I think it's true. Because I have a technical orientation, I'm an engineer. I think about solving the problems and how I can use technology that I understand today to make it happen. And it usually happens in a foreseeable amount of time. But then think about the world's inventing along with you. Most of these things I don't know going on. All of a sudden they show up in odd ways. And then all of a sudden they get reconfigured in a way using commonly used platforms that didn't exist when I was first thinking about it. Think about the cell phone platform. That's being used for everything today. I would have thought of that as a product, not a platform, right? So it's just a different way of thinking about these kinds of things.
And look, you made a comment about maybe companies should have finite lives, and that this is something I've been thinking about too. Is should we change our expectations about some of the most iconic businesses that you expect just to be around for forever, and certainly the shareholders' expectation is such that what they invest in isn't going to be wiped out. But yeah, I do wonder what should the end of an era look like for a business? Should there be an exit, or should companies where their most profitable days have gone, should they be setting up separate offshoots that maybe they don't necessarily own entirely to disrupt the original business? Have you what thoughts have you had in this area?
I've thought a lot about it. I don't know if I've got any answers. All different companies react to the changes that are imposed upon them by the rest of the world differently. Some companies start to, you sort of break yourself up, right? Just to force yourself to do that, right? There was a book I read in the early 90s by a fellow named Hardy, I think his name was, called The Age of Unreason. And he was trying to describe what was going to happen. I would call him a futurist, right? And I remember reading this, thinking about how it might apply to my world at that time. And he talked about companies being shamrock companies, where the center core would be the corporation. And then there would be all these little bubbles attached to the outside of it, be separate entities, but closely associated with it. And the people who worked inside the core corporation would have relatively short, intense working lives. He numbered them in hours, I remember. And then something 50,000 hours or something. And then they would move to these, as they got older, they would move to these separate little shamrocks outside, the wings of the shamrock, and they would do support activity for the rest of their lives or whatever. And then maybe that shamrock would move to another company or something like that. He was describing something like that. And I remember that to this day, because it sort of looked like what was happening to Kodak. Kodak was breaking up into lines of business. We were taking the big core and trying to break it up into more responsive lines of business, smaller little bubbles. But they never really let those individual bubbles be independent. Okay? They were still under the same umbrella. They would give you separate P&L and all that, but they really controlled everything, right? They never really let go. So in a sense, they didn't really do what was being proposed by Hardy, as I remember. And so I think how Kodak reacted was they should have let go of some of this stuff. You can either stick with the market that you know, or stick with the technology that you know when you're dealing with a transition. And we stuck with the market that we knew, imaging. But the technology then took us out. Right? If we had stuck with the technology we know, which was coding very complex materials in very difficult circumstances on thin webs, moving very high speed, very big webs in the dark, could we have utilized that to make other businesses? And probably we should have done more of that, in terms of this transition. And then our company would have moved from being a photographic company to a company making industrial materials or something else, right?
Mm.
So that's, I can speak from my experience at Kodak. All I can tell you is that companies today are dealing with bigger changes that are happening faster than we dealt with.
Yeah, I mean, it seems pace is a real key to success today. There's so much competition. There's this a lot of techniques that are used within small startups that certainly, looking back, often larger businesses didn't leverage. But it seems like these startup type concepts uh, are really important, and big business has to embrace those things, and find the right mechanisms to let innovation happen at pace, and to decide the right timing. And that's the challenging thing, particularly if you're disrupting an existing revenue stream. And I would wonder, in some cases, whether a business would actually in the boardroom work out and calculate that actually they'll be better off to let themselves die than to focus too much on the new innovation, because then they might actually generate more revenue in some cases by stringing it out, which you could say to a degree is what happened within Kodak, right? It was looking at, well, if they moved too fast down the digital track and promoted it too broadly, then that was going to disrupt the film revenues maybe quicker than they would otherwise. And of course, there is only one set of reality, one set of facts of what happened. So you don't know what might have happened, had there been a faster move into digital within Kodak.
You don't know. They certainly had the technical vision of where it was going, but we just couldn't come up with a successful business model. We talk about today, I see all the innovation startups and maker spaces and all these kinds of things. And in a way, I'd like to describe it as the democratization of innovation. Okay, because it allows everybody to be doing it. And when you talk to young people today, when I talk to young people, I like to tell them, when you're inside an organization, you have a boss and there's a culture and all that kind of stuff. Your job is, if you're not annoying your boss to some degree with a new thought that is uncomfortable, you're not doing your job. Okay. And too often we think we have to go in there to get along, to fit in, if I don't fit in, I can't get power, and that's the wrong way to think about it, in my view. And the company should not encourage that. The company should encourage, have I been made uncomfortable today by any of my employees? Because then I know that something's happening, I mean, the people who best knew how photography was going to be done away with was the people inside of Eastman Kodak Company. I know that because I work with them. You could take a look at the intellectual property trail. They knew it. They knew it was coming before just about anybody. And they had the right answer just about before anybody. Okay. But it was hard to let go of what we were successful at. Again, we get back to the cultural challenges that a disruption poses and how to deal with that. And I don't know if I have the answer, to be honest with you. There are certain suggestions you can make, but I don't know if I have the answer. And to extrapolate that to today's world, all I can say is it's faster and it's more severe. The platforms out there are amazing today. People can pull together technology at such a high level with a relatively low investment. And even with a skill base, you don't have to have studied something for 20 years in order to make a contribution in these fields.
And there's so much information that's readily accessible, and so much access to other experts. So I think Kodak invested in so many different businesses, either through acquisition or smaller investments during probably across most of the time that you were with the business. But at the end, it didn't seem as though those partnerships and acquisitions delivered the sort of outcome that we might wonder about now. Were you able to see some of those things going on, and does it leave you with any lasting impressions on what might have gone wrong there? Was that culture again with the behemoth of Kodak maybe pushing its culture onto these other firms?
So there were obviously, that you're correct. There were a number of acquisitions that were done, a number of businesses we got into and got out of, got back into and got out of again. I think the biggest acquisition, of course, was the Sterling Drugs in the late '80s, early '90s, and that was an attempt to say, I'm going to stick with the technology I know, and I've got all this massive amount of chemicals and a big portfolio of interesting chemicals. Can I apply that in the drug field? Right. That was kind of a simplified view of that, and that turned out to be not the case. Maybe you could argue that due diligence wasn't done there. Okay, and we sold that. I think when George Fisher came, he sold that a few years later. So that was the biggest acquisition that represented a cultural. I know this area better than this new area, new technology. There were many others, like inkjet, for example. We got into inkjet and got out of inkjet, got into inkjet, got out of inkjet several times, because it was sort of fit our culture. Again, it was sell a high margin material for something that once the person has made the investment in the printer, that they would keep buying that. And by the way, HP did very well with that, as well as Canon.
Of course.
But we thought we were in that earlier than that. Okay. And we could never stick with it. I think what happens is you come up with an idea inside a company, and it's easier to sell the idea because it's a change. We got to do something. So they do this. And it sort of is plausible. Hey, we'll sell ink at very high margins. Sort of reminds me of selling film at high margins, right? And so they go and do that. Then it requires a lot of work. It takes longer than you think. It requires new marketing channels, new skills, and they sort of lose interest in it, and then they decide to get out of it. So there's a number of examples of that occurred there. We tried different things that just never. We tried the photo sites. So I forget the name of it now. But Kodak had that internet presence on the. People didn't get prints, so we just abandoned it. Maybe we should have thought about it differently. I'm not suggesting that we should have anticipated all the social networks and all the rest like that. We just didn't think broadly enough like that. But to think that Instagram comes along and does so well with, I don't know how many people they had, like a half a dozen or something. I don't know.
It was an incredible story.
We knew all that. We could have done everything they did, but we didn't. And I think that's, again, getting back to what you're predisposed to thinking about the way the world should be.
And the scale challenges, just the size of Kodak versus the size of some of these startups, and that brings with it some challenges as well, doesn't it? All the layers to go through to make things happen.
Well, there's the size, as you rightly point out. There's also the culture and the longevity. Remember, this company has been quite successful for over 100 years.
Incredible.
So all these companies we're talking about today, how successful they are, come to me in 100 years, and if they're still around, let's talk. All right? So let's talk about that. Don't forget the longevity. A lot of people who worked at Kodak, their grandfathers worked there, and their fathers worked there, their families worked there. Okay, so there's that. So it's the size of it was for sure. They treated their people very well. This company was regarded as a model employer, the way they treated their people, and the people liked the company. To this day, you'll find a lot of people speak very favorably about working at Eastman Kodak Company. I'm one of them. So it was a good company to work for, but the size of it was hierarchical to a large extent. It was slow to change organizationally. They did try changing it, becoming more nimble, but they never really let control go. You know, I mentioned those lines of business. The lines of business were formed. You be agile. Go off and do something great. You know, and then when you want to advertise a transceiver, don't do that. Don't do that. that kind of, because you're really not separate companies. These companies impact each other. For example, if you're putting on an electronic product that may or may not compete with a product of another business unit, right? Your marketing arm of that business unit has a problem with you. They'll go to upper management and say, hey, I bring in so much revenue and profit a year. They don't bring in anything. Stop them from doing this because it's going to impact me. As a businessman, it's rational to put controls on it. So really, the size of the company and the things they tried really weren't as effective as they were thinking they would be, because they never really let go of control.
So looking back in hindsight, if there were 2 or 3 specific things that you think that the business now, with all the knowledge and all the information that we have, could have done differently, what are the things that would stick in your mind as what might have been the playbook that would have seen Kodak be a much more successful business today?
If Kodak could have changed their culture, their management culture, extensively, and they reacted soon enough. And when I say soon enough, I mean like in the late 1980s, okay? I think reacting before that would have been imprudent because the technology was not really proven. I can speak with some authority about that. There were questions about that. But in the late 80s, in my opinion, it was pretty much established. Electronic imaging was coming to the forefront. People were buying VCRs and those kinds of things. It wasn't necessarily digital, but it was electronic imaging. So if they reacted then, and they could have somehow started to get into the electronic imaging field some way, maybe making VCRs or something. I don't know. We know how to manufacture everything. We could have done some of that stuff. Or if we had acquired some of the California startups, maybe move part of the company to California and truly given them independence. I think that would have been the most difficult part. Kodak was always command and control. And it was because you had to control everything. Think about what they dealt with. Their whole imaging chain was control. When you bought film, it was manufactured by Kodak. They controlled the chemicals that we used to develop the film. They made the machines that developed the film, okay? They made the printers that printed it. They made the paper that it was printed on. They controlled that whole imaging chain. And by doing that, they were able to sustain a business for over 100 years of superior image quality and good customer value. Okay, now all of a sudden electronic imaging comes along. You can't control anything. Algorithms written by somebody else, printed on printers written by somebody else, on computers that are built by somebody else. You don't control any of that stuff. So that was against the thinking of the company. We've got to control these things. So you'd have to get rid of that mindset and go more to like what we call open source kind of thing now. And that would have been difficult I'm talking about people now, people to do. So you would have had to blow the company up to some extent, geographically probably separate themselves, use the consumable business, which was very profitable, to fund the initiatives that are done and really truly run by different people with a different mindset. And then they would have had to adapt to the rapidly changing times of the 90s in order to be successful.
That wouldn't have been easy or something to come natural at all, right?
Well, if you were a shareholder going to a shareholder meeting, you would have to ask the CEO. You have to answer the question: you're taking all this money and you send it out to these guys in California, which, by the way, you don't seem to be able to answer any questions about because he doesn't control them really. And by the way, they're not making much money. Why am I investing in this stock today? So maybe another idea would be to take the company private at some point. I mean, I'm not a big corporate finance guy or anything, and I'm sure there's difficulties to doing that. But I would think shareholder pressure would have precluded a lot of what I was talking about before.
And potentially the sort of thing that leads to a chief executive getting displaced.
Yeah.
Wow.
Oh, absolutely. Yeah. Because his job is to represent shareholder value. I mean, in addition to, all of the other things. And he would have had to explain for a period of time why the profits of this company are going to this loser that you don't seem to want to control. That would have been a difficult thing to do.
I mean, I just think these things are incredibly challenging. That's why
I don't
I'm
know how many
enjoying
companies.
exploring it, and there aren't too many that have survived. I mean, Microsoft
Microsoft has got issues.
is one that's been
Yeah.
interesting to follow because I
Right.
mean, it looked like they were going to miss the whole cloud thing, and it's
Give them a disruption like quantum computing and see how they react. These are the kinds of disruptions that are going to come. Artificial intelligence, and these things when they hit are going to impact people. Well, look at the car companies. How are the car companies going to look when you have driverless cars? I heard a futurist talk about 17 years you won't be allowed to drive, right? And I'm thinking, will anybody care what car they drive if they don't drive it? They just get in it. Will anybody care?
no.
Who makes it?
That-
They won't own them. They'll rent them. It'll be Uberized or something. Think of what that's going to do to the entire automobile industry. That's the disruption that Kodak was dealing with.
Yeah.
That's the kind of thing. Can companies successfully deal with that, or should they? Should they just reinvent themselves? We're no longer needed.
Yeah.
The reason we were created, we're no longer needed.
Can you imagine a chief executive
But that's what
standing
has
up
to be said.
and saying that? Right?
Kodak used to say that you press the button, we do the rest.
Yeah.
You don't have to do the rest anymore. So therefore, you don't need it anymore. So companies really have to take a look at why they were created and their basic function. Is it needed anymore?
Well, it's that diversification, and I think, I look at BlackBerry, for instance, and, they were very popular for a while, but they didn't have the broad diversification. Now, they still exist in a form today.
Yeah.
But Microsoft was competing alongside them in that sort of smartphone space there for a period.
Yeah.
But Microsoft had a whole lot of revenue streams, so they weren't sort of caught like Kodak was, where and I don't know haven't delved into the exact numbers, but Kodak was so heavily reliant on film. There wasn't a whole lot of different streams that had similar sorts of revenues. So
most companies have one or two products that supply 90% of the profits, and Kodak was no different than that. We had many products.
Yeah,
and much. I mean, the portfolio was enormous.
Yeah.
But if you take on which are the ones that really make the money, it's like Sony. PlayStation games. That was, that's where all the money was, right? There wasn't on TV sets.
Yeah.
So to me, there is that, and you have to say fundamentally is where I'm getting all of my revenue from. Okay, and I've been doing it for a while, and I'm really good at it. Is that going to be needed anymore? Fundamentally needed anymore? When quantum computing comes along, will Microsoft be needed anymore? Will it be done by some guys growing crystals somewhere else, right? I mean, it'll be the same kind of a thing, right? Google's got the same thing. When bandwidth gets so high and information gets stored irreversibly everywhere else, who cares? You know what I mean? So to me, it's that fundamental question of, why do I exist? What do I fundamentally exist? And look at the revenue stream, see where the profits come from, and is it ever needed anymore? Not wanted, needed.
Yeah.
That's what it comes down to. And I think all companies have finite lives.
And then you look at Apple. Well, the large majority of their revenue comes from the iPhone, and Google are giving away the building blocks for their phones for nothing. And look, in some markets, Apple is still incredibly dominant with their phones, and other markets not so much. But their margins are so high that it doesn't seem to matter. But they're going to have to keep innovating. And
the phone market for Apple
is
that's where they make most of their revenues. Their profits is on those phones. And how many people need to buy a new phone all the time? Most people don't need a new phone all the time. I know and the irony is, when they come out with a new phone, what do they advertise? The camera.
Yeah.
You gotta laugh at that. I mean, it's a riot. It goes back to pictures, and Kodak owned that business.
Yeah.
That's what drives me nuts.
Well, it's been a great discussion, Steve. Thank you very much for your time.
Oh, my pleasure, Paul. Thank you very much for coming to visit with me.
So many great insights there, and thank you for sharing your story and your stories from within the world of Kodak, and for your insights as we look back in time, and we have some benefits in being able to do that with hindsight. The Kodak story is certainly one of a company of incredible innovation and incredible achievements, and the same goes for the inventions that you were involved in. So congratulations on your great work.
Well, thank you very much, Paul. I appreciate you coming to visit, and I like telling the Kodak story. Kodak was a great company. He is a great company, but for over 100 years, it provided real customer value. So,
we look forward to seeing what Kodak can do next.
Yeah, they're involved in a lot of things.
There's still a lot going on there.
Yeah, there's still a lot going on there, and they're diversifying into a number of different areas, and that's it's encouraging to see.
Mm.
Yeah.
All right, thank you.
Thank you.
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.